I've heard that some companies put crunch teeth on an enclosure bore and they claim that this works as strong backing. I don't agree with this, and here's why. Let's start with the theory behind how a friction ring, or also known as a crunch ring, actually works. A friction ring relies on friction force. Friction force is the product of two things. The normal force, that's the clamping force that is generated by the grip studs, and the coefficient of friction between the strongback and the pipe. So in order to generate friction force, you need to have positive clamping force on the pipe. When we design friction ring strongbacks, we deliberately leave a gap between the two halves of the strongbacks. That way, when you torque the studs, the halves of the clamp don't come completely together. The pipe itself takes the load. That load remains on the pipe, creating a positive clamping force that translates into a friction force. Now let's compare that to an enclosure bore with crunch teeth. For an enclosure to seal properly, the two halves of the enclosure must come completely together. So what that means is that the stud load that's being applied to the enclosure doesn't strictly go to the crunch teeth. It's distributed across all of the surfaces of the two halves of the enclosure as they come together. So some of the force will go onto the crunch teeth, and the rest of the force is going to go onto the split line surfaces of the enclosure itself. So what that means is that you don't strictly have an isolated clamping force on the crunch teeth and directly on the pipe. So if there's any temperature cycling in the system that causes the pipe to shrink, whatever clamping force that you have on those crunch teeth could be completely removed and might be lost entirely. At that point, the teeth aren't working as a friction ring based strongback at all. They're relying more on their shear strength. As far as I know, there's no accepted way to guarantee either the strength of those teeth or the friction force that they provide inside an enclosure if the two halves come completely together. So if a company proposes that they're going to use crunch teeth on the bores of an enclosure as a strongback, which would be very convenient in many cases, here's what I would ask. Show me the engineering theory that proves that they can maintain a positive clamping force and positive friction force on the teeth. Also, show me your test results. Not just one-off tests, but comprehensive testing across different materials, different operating pressures, and especially different temperatures. From what I've seen, the testing so far in this industry has been limited and not nearly broad enough to justify this approach. Strongbacks are a safety device, and they have to be designed using solid engineering theory and backed by reliable math and, in some cases, testing. While I wish the crunch teeth on enclosure bores could be considered safe and effective, it would often be very convenient if they were. The reality is that without the theory and the data to support it, they simply do not qualify as a true strong.